Hello and welcome back. Thank you for staying with us, and we will start right away with miniaturized Ethernet connectivity for device integration for being built on the PCB. And I would like to welcome Marian and Joachim. Thank you guys for joining and looking for your insights. Stage is yours. Thank you.
Thank you very much, Kilian. So welcome and hello, everyone. So our part of the day is about miniaturized Ethernet connectivity solutions, and we are going to show you what HARTING is doing to meet this increasing demands and which products we are offering. And the reason for the increasing demand of miniaturized Ethernet connectivity solutions are the megatrends and challenges of the industry of our time. And on the one hand, we have miniaturization. So devices and electronics are becoming smaller and smaller. We have digitalization, the number of devices, and performance requirements for devices increasing sharply. Robustness, so devices and connectivity must become more robust because of the use in harsh environment. And last but not least, sustainability. So we need new technologies to make better use of our limited resources and protect our planet sustainably. And what products HARTING is offering, and which are those? Joachim, I guess you're going to show us now, right?
I will do so. Yeah, thanks a lot. So we from HARTING, we offer many different solutions for Ethernet applications, from cabling devices, panel feed-throughs, but also a huge topic on device integration. Yeah, so everything which is soldered on the PCB and used for transmit Ethernet from the cabling side onto the device. And the different solutions we have is on the one hand side, the terminal blocks. So I would say the cheapest and easiest way for low demanding applications. Second one is we have a huge range of M12 PCB connectors. There we have also a new M12 Transformer variant, which supports a lot of trends like space saving. Then we have iX Industrial, so the miniaturized, robust, and high-performance, reliable alternative for the RJ45 jack in industrial applications. We have the mini push-pull. It's an IP65 rectangular housing with a plastic material, but very robust and reliable. And last but not least, the topic which we have connected a lot of times today, so the topic of single-pair Ethernet, we will get to know more details about the PCB connectors. So let's directly start in terminal blocks. As I mentioned, so terminal blocks is the most cheapest way to connect devices with Ethernet. It's meant for, I would say, low performance applications. For example, 10 Mbit, 100 Mbit. The technology even is ready for gigabit Ethernet. Of course, you need to distinguish between the cable lengths you have. So it's, of course, not a high-performance connection system, which is meant for long-distance gigabit Ethernet transmission. But for certain applications, really, the PCB terminal blocks, they are a very good solution. So what we can see here is an outlook of HARTING to the Hanover Fair. The Hanover Fair in Germany is the industrial exhibition where we will present our new terminal blocks here for Ethernet. And the portfolio you can see is our starting portfolio. So we have single poles, which you can flexibly place one after the other on the PCB. We have blocks with a contact pitch of 3.5 millimeters and also 5 millimeters. All this is covered with different termination techniques, of course. So we have push-in termination, which from my point of view is the state-of-the-art termination here to connect devices in a reliable and fast way. But of course also we offer alternatives. One is IDC, and we also offer the spring clamp termination. Yeah, so that's the portfolio we basically offer for terminal blocks for Ethernet transmission. Now I would like to pass over to Marian.
Yes, Thanks, Joachim. So the next product is the M12 Transformer. And so the M12 Transformer combines the well-known M12 interfaces with magnetics and common mode chokes in one component. And this makes a very small and compact design and make the integration into your device much more easy as a discrete assembly. But what are magnetics or transformer and why they are important in your application? So transformers are doing the galvanic isolation in your device, so they separate your circuits in your device from the MDI to your MACPHY, and this protects your device from surges. And so in addition to that, transformer have also a second very important task in your device. So transformer reduces the common mode noise rejection and are doing the signal filtering for better signal integrity behavior and purposes. And the transformer is responsible for the physical attachment between the MDI, so the media-dependent interface, in this case is a connector, and the physical media attachment, so the PMA of the PHY, of the input of the PHY. And so we at HARTING offer different versions. So we have the well-known interfaces in D, 4-pole, and X-code 8-pole mating phases according to the IEC 61076 standardization range. And the products are ready for fast and gigabit Ethernet, so for 4 and 8 wire 100 megabit up to 10 gigabit Ethernet. And the connector is designed in a very robust way to meet the requirements of the IEC 61373. And these are requirements out of the railway standards. And the space saving compared to a discrete design with the single components is about approx 30%. And we have also a very space-saving surface-mounted technology, soldering technology, so that you can use the other side of the PCB for other components. And on this slide, you can see which products HARTING offers. So, and we have two product ranges. So we have a vertical and an angled horizontal design with SMT contacts in 3 versions. So decoded for fast Ethernet 100 megabit, X-coded 8-wire Ethernet, gigabit Ethernet up to 1 gigabit. And for high performance application, we have the X-coded version with an additional shielding inside the connector for data transmissions of up to 10 gigabit per second to cover the big range of application possibilities in the industry. And the next products we are going to show you now are the iX Industrial in IP20 and IP6567 push-pull housing. And Joachim, now it's your turn again.
Yeah, thanks a lot, Marian. So this is one of my, I would say, my favorite products, the iX Industrial. Because we all know that the RJ45 was originally designed for telecom applications, but found its way as the only IP20 Ethernet interface right from the beginning, also into the industry. Most customers I visit use it, but always say, oh, the robustness and the reliability especially is not the kind of quality we typically expect for our industrial applications. And if there is a service interface somewhere in the world, and it is maybe because a certain connection of PCB jack and cable assembly from any supplier the customer has selected does not work and the machine stops, then it's always, I would say, an image damage for the supplier of the machine because his machine failed. Yeah, so means the interface there is very important. And there was since years and years, from my point of view, there was an elephant in the room that something new must be there. But of course, it's very, very difficult to develop a new interface as an alternative for the RJ45 because we talk about Ethernet applications, so means applications where devices of different manufacturers have to be connected to each other. So means it could not be that one company is offering a kind of proprietary solution. Yeah, it must be a standardized one, and it must be an alternative which is supported by many, many different companies. So The weak points of the RJ45, which I have explained, we would like to salute. We have here, you can see our hero. It's our iX hero. You might have seen on the exhibitions during the last years. So we directly from the beginning standardize this interface. Yeah, so this is not an HARTING proprietary interface. This is an interface standardized right from the beginning. And not only from HARTING, it was done with other companies, for example, like Hirose from Asia, who were involved in creating the standard. So first, very important message, the solution iX Industrial is a standardized solution. Today, I can say after some years, it's not just HARTING and Hirose, there are also other companies, so really it's a future-proofed interface where visual connectivity will be available globally and from different sides. So we have started with a portfolio of PCB jacks, you can see here. We put a lot of attention for the coding because coding A is meant for Ethernet applications, but there are also sometimes ways to miniaturize your device by, for example, replacing a 9-pole D-sub connector for signaling. Yeah? So this is why we have integrated another coding, the B coding, as an alternative. It's used, by the way, already very often because if you compare the space of an iX and a D-sub, it's a completely different world. And in the meantime, we even are on the way to implement a C coding because there are further applications where customers said, okay, another coding is needed. So it means the portfolio is spread. This standard is not just a connector standard, it's a standard which is used by different user groups. For example, the P&O for Profinet in May of the year 2021 officially approved the iX Industrial interface as a Profinet conform interface. Yeah, so means if you design a Profinet conform device for inside cabinet applications, you can use the iX and certificate your device according to the Profinet requirements. Another example is the camera vision market. So in the GigE standard, also here, this high performance miniaturized Ethernet is already implemented in the standard. Yeah, so it means standards very important for the connector, but also for the different applications and user groups. So if I talk about miniaturization, what does this mean? If we compare the PCB jack of an RJ45 to an iX Industrial, we have an incredible space saving of 70%. The mating phase is, of course, fully miniaturized. The weight is also reduced due to that size. And if we compare now a device with an RJ45 jack arrangement to an iX arrangement, we can see here on a very impressive way how many interfaces you are able to integrate more on a device like or compared to an RJ45 interface. Yeah, so it's really a very space-saving connector. We can see it here, 5 RJ45 plugs compared to 9 iX Industrial plugs. If you become smaller, it's always the issue in industry applications, how small can you be by still keeping the robustness industrial applications require. So it means we put a lot of attention and focus on to make the device not only small, but still on a very robust way or level. So what we did is we implemented 5 different shielding contacts with a very massive through-hole reflow pin in order to make sure once the connector is assembled onto the PCB, it's really very robust. And if you have a sample in your mind, I'll show you later on, and you compare it to an RJ45, you really feel and see that robustness. Furthermore, we have integrated a locking principle with 2 locking areas, let's call it areas. Yeah, not for the RJ45. There was just one lever on the top, but for the iX you have really 2 levers, one from the top and one from the bottom. So also the cable to PCB connection is done in a very robust way, and also mating cycles and shock and vibration resistance is done really for industrial applications. So means the iX Industrial really is the interface for miniaturized industrial devices. This one is here a short portfolio overlook what we have. So we have on the right-hand side the different jacks. I already explained the A coding, the B coding. The C coding is on the way, available recently. We have different arrangements, so angled vertical connectors, horizontal connectors, and also pure vertical connectors. And we have the cable side for IP20 today with a locking lever, but also now, like on the Hanover Fair, we will launch the new IP20 cable plugs with the push-pull locking. And also, what we have launched in December are IP65 solutions, which I will explain you right now. So IP65, we had the demand from customers saying the interface is nice, but we have not only IP20 applications. It's really a nice solution to replace, for example, an M12 X-coded connector or decoded connector, because those connectors are not just, I would say, not the cheapest, but not needed in every application. This is why we have integrated the interface of IX into our mini push-pull housing. Yeah, so far we had a V4 push-pull housing where we have implemented a USB interface. We have seen on yesterday from the back-off presentation an RJ45 interface, and now we have miniaturized exactly that housing, that principle, and integrated an IX industrial interface. So it's even smaller than a V4 housing with a RJ45. I think from the requirements, I don't need to explain too much. 30% less space, vibration and shock-proofed, and really suited for IP65 applications at the machine and even somewhere outdoor to have really a nice solution here. All right, I would say that for the mini push-pull. If I'm allowed to, I would shortly show you some products in real before Marian starts with the T1. So I go to our, we call it kitchen, and I have presented here some samples for you. So what you can now see here, this is the mini push-pull, the IX mini push-pull, the cable plug on the right-hand side. This is a device side. Yeah, so we have for the device side two options. One is to use it as a panel feed-through, here with an adapter from the PCB. Yeah, so to go from the cabinet here from the outside, mating it, it makes click, the job is done. Yeah, you just need to pull here on the housing to unmate it. Yeah, so really a very nice and flexible solution. Here shortly I will show you the IP20 solution. So that's a really impressive, I would say, impressive comparison of an RJ45 jack. You can see here, everybody knows, compared to the size you need to an IX industrial PCB jack. Yeah, so really a very, very miniaturized and very nice solution. And last but not least, just to complete it, I showed you the terminal blocks in advance. And here you can see them, the modular ones. You could connect one after the other flexibly, and also here the other versions, terminal blocks. All right. Now I would say, Marian, I pass over to you. We have learned a lot about single pair Ethernet, and I'm very curious to see now which connectivity we have.
Yes, thank you, Joachim, for the presentation of the products. Yes, so the last topic in this session is about T1 Industrial for Single Pair Ethernet. And as Joachim already mentioned, we have already heard a lot this morning about Single Pair Ethernet, about the technology, about PHYs, chips, magnetics, and the SPE Industrial Partner Network. And now we want to take a closer look on the products we at HARTING developed especially for Single Pair Ethernet, which is called the T1 Industrial. And so I have mentioned the trends and the challenges of the industry, and also Joachim has also named this. And I will just give you some key facts of the mechanical and electrical performance aspects we have achieved and we have focused on during the design of the T1 Industrial for Single Pair Ethernet. And we have chosen the typical Ethernet interface design for this connector, which means we have the plug side, the cable side designed as a male version, and the device side as a female version. So the whole connector system is designed according to the international IEC standard 63171-6, which is widely accepted, which is referred in all the international standardization committees, IEC, ISO-IEC, IEEE, TIA, and so which is also supported by all the members of the SPE Industrial Partner Network. And so this standard covers all variants from IP20 up to IP65, 67 with a big amount of mating cycles. The product covers wire gauge range from wire gauge 28 up to 22, and the whole system is very robust. It is shock and vibration proofed according to the IEC 61373, category 1B of the railway standards. And so another big topic is the electrical performance, because we have heard that it is always a conflict if we want to achieve more of this trends or meet or serve more of this trends simultaneously, because robustness, miniaturization is always a conflict. Electrical requirements are not so easy to meet. And so our purpose was, during the design of this connector, to have the best combination of all the different aspects. And so we wanted to design one connector for all applications, for all IEEE standards. And this is why we have designed this connector, so for all transmission standards for single per Ethernet. And this means this connector is ready for applications from 10 megabit per second up to 10 gigabit per second, and has a very high voltage proof of up to 2.25 kilovoltage DC, so that this also meets all the requirements of the network device standardization made by the IEEE. And the whole connector is 360-degree shielded, made out of stainless steel for a very good signal integrity purposes. And yeah, as we have learned this morning, so single per Ethernet is not only a connector or a cable with a reduced amount of wires and pins. So it's a new physical layer. And this means that we can't use the existing network infrastructure. And so not only the cabling in the connector can become smaller, so we have also some potential on the PCB to save some components, such as magnetics or common mode chokes, where we need one component per twisted pair. And if we reduce the number or the amount of twisted pairs, we can also reduce this amount of components. And you can see on this nice picture, so how small the whole interface, so the connector, cabling, and the components on the PCB can be with using single per Ethernet. And the space saving is about approx 50 up to 60% compared to standard RJ45 or M12 DNX coded. And you can also see on the left-hand side at the bottom, so the volume reduction for multi-port applications, 4-port RJ45 compared to 4-port single per Ethernet. So, and there's also approximately a space saving of up to 50%. And yeah, so now I want to show you how these products look in real. And therefore, we move over to our table, where Joachim already showed you some of the components, and also Matthias already showed you some of these products. But I want to give you some more details about that. And as I mentioned, so the IEC 63171-6 standard covers all the products from IP20 up to IP65, 67 in different form factors from M8 up to M12. And yeah, so the nice thing about it is that we already are able to offer a big portfolio and variety of different cable connectors as well as PCB connectors. And therefore, I want to show you what are the nice features of these solutions are. And yeah, of course, we have this very small IP20 version. And In addition to that, we have for our IP65, IP67 versions, different angled versions in different lengths, and we have also vertical versions or right-angled versions in different heights. This is very important for switch applications because it is possible that you have to combine single per Ethernet interfaces with, for example, different M12 applications. For example, power codings, power L or power K, M12 codings. And then it's very important that all these connectors are on the same height so that you don't have any jumps into your PCB. And yeah, we guarantee that we will offer all the different versions. And we started with a 12.5 millimeter version, which is fully compatible with the THR portfolio of the HARTING M12 versions. And also a very common standard is the 8 millimeter version, which you can see on the left-hand side. Unfortunately, there is no market standard, no standardized standard from the standardization consortia, but there are market standards, and 8 and 12.5 millimeter are very common. And the nice thing about these connector solutions are that also the waterproof versions are also fully compatible with the IP20 versions. So because we use the same components. And for example, for test purposes, if you have to flash the software or have to do a service at your machine, you can always use the IP20 version because we integrated the locking mechanism into our waterproofed IP65, 67 versions, and so you can also use these versions. And yeah, at the end, so we will launch to the Hannover Fair different versions. So IP20 version and M12 versions are already available since the last year. And for the Hannover Fair, we will launch on the one hand the terminal block solutions, which Joachim showed to you for single per Ethernet for low performance applications. And we will also launch the M8 versions, M8 two-pole, and M8 hybrid versions with 2 additional power pins to transmit power up to 400 watts. And so the portfolio will be completed in the next years with all the products you know from standard Ethernet, RJ45, M8 and M12, D and X coded. So everything which makes sense will complete the portfolio in the future. And yeah, that's it from my side. Joachim, I guess nothing to add. So, and I will hand back to Kilian, who will show you the next presentation.